Welcome to Chemistry Session 2 today. So we had Session 1 yesterday with the multiple choice. Today we have Session 2. So today's team, let me introduce you to the team. I am Dr. H, and I have the best moderator I could ask for. Shadna is back. And Brian, although I've written there tech magician, it's actually a misnomer, because if he lived in the Middle Ages, Merlin would have some real competition. I think he's more like a wizard than a magician. I need to change that slide. So today on tap today, we'll be talking about, of course, the 2021 AP testing, how to prep for the AP chemistry. My focus today will be the short answers and how we, Princeton Review, can actually help you out. So as far as the test days go, notice that this is a change from the past, where it is offered on 3 dates. And while it is offered on 3 dates, the difference is your school gets to decide. So on May 7th, it is a local, it's a paper and pencil, and it's in your school only. On the 25th, it's again local at 8 a.m. local, paper and pencil only, and in your school. The June 10th is a digital, and it can be administered at your school or at home. And to standardize the times, because it is digital everywhere, it's 12 p.m. Eastern Daylight Time. So some of you might be taking it earlier, some of you might be taking it later. Just depends on where you are geographically. Okay, so the paper and pencil, I showed you this slide yesterday. And this is the way it's going to be on the paper and pencil, like the quote unquote traditional AP chemistry tests we've had in the past. Multiple choice, which is section 1, followed by section 2 with 3 long responses, 4 short responses. You have 105 minutes for that. Now, the difference is that if you look at the digital test, the multiple choice is not that much different, right? It's still 60 multiple choice questions in 90 minutes. The difference is that if you see one multiple choice question, you can't go to the next one unless you answer this one. Section 2 is where the differences are more dramatic. Section 2, notice that the number of questions you'll be working on are fewer, the ones that actually need an actual response from you. And you have 40 multiple choice questions for which you're given 60 minutes. So if you add up the times, you still get 105 minutes. So the time is not different, but the distribution here is indeed different. So the salient features between the digital and the paper and pencil is that in the paper, you have a total of 60 multiple choice, 4 long response, 3 short response questions, and calculator is not allowed on the multiple choice question. And that's why the session that we had yesterday, I was trying to show you the calculation shortcuts that you could take because you are not allowed a calculator in the multiple choice. Of course, the assumption there is that it's a paper multiple choice. If you're taking the digital one, you have 100 multiple choice. Instead of 4 long response, you have 1. And instead of 3 short response, you have 2. And calculators are allowed on all sections. So will the tests be different? Yes, they will be different. How different? We don't know. What I do know is that on the 8th of this month, there are practice modules that you can go take on AP College Board's website. Do that. Do that because now it will show you some of the nuances. The differences between the 2020 and the 2021 is that now you need to enter your response via a laptop or a desktop. No more smartphones or tablets. You can't handwrite or photograph your work and upload it. And no out of order answering of questions. This is big. This is huge. Because not only does it apply to the multiple choice, it actually applies here, well, actually here as well. So if they give you a long response question, that's what you need to work on. And when you are done working on that, you get the next one. You get the short response question. Now, within a question, within any of these questions, you can move back and forth uh, through the different parts A, B, well, A and B for the short response, but the multiple parts through the longer response. But once you answer the last section and it moves to the next question, you can't go back. And that is really for them to prevent any type of cheating or a possibility of cheating. So you do have to applaud them for trying, to be fair. The methods we may disagree with, and these are, of course, they are learning too, so they are trying as well. Um, so will they change it? They may. You don't know. Uh, these are actually based off of the announcement that came out on the 8th. So it came out, what, less than 2 weeks ago. So that's what all of this information is based on. Okay. You now last year you needed a continuous internet connection. So if your internet crashed, uh, you are out of luck. Here, at least you need an internet connection at the beginning of the test. You need an internet connection at the end of the test. And if you know you have a temporary brownout or the internet stops working a little bit while you are doing the test, during the test, it's okay. The software will save things to where you were and upload them. You can't leave during the 20-minute break between section 1 and section 2. You got to be on camera the whole time. Like before, you need to check in 30 minutes before the start of the test. And if you downloaded software last year, you will have to download new software this year. Your high school IT department, your high school AP coordinator will be able to help you with that as well, if that is the way you are actually going. Okay, so keep checking as these may change. Although we're so close to the test date, it may be unlikely now that they will make any changes. I mean, I think the window for making any changes may have, in my best guess, would have closed like last week. Incidentally, Shadna is my moderator, and that means that I don't see the chat. She sees the chat, and if there are questions, do put them in the chat. She will then forward them to me, and I will try to answer them as best as I can. The last thing I want is for you to have a question and it is not answered. I mean, certainly a looming question like this one is uh, is no fun, and I've put it here at the bottom right corner. So if you do have questions, certainly go ahead and ask them. I will try to answer them. And if you have comments, go ahead and make those as well. Okay. So the units that are covered, these are the units that are covered. And as you see, most of these are about the same. Okay. Here is one that's different: intermolecular forces and properties. Acids and bases is a little bit higher. And thermodynamics gets a double hit. You have applications of thermodynamics and you have thermodynamics as well. So the areas that actually have a little bit more are actually the supposedly the harder areas, and and also the areas that, as a chemist or as somebody who worked as a chemist at one point in time, I will tell you these are the ones that are the most important as well. Okay, so prepping for the AP Chem. What I do have here is I have a bunch of questions that I will run through. And as I run through these questions, I will try to uh, demonstrate some of the techniques that I will talk about as far as approaching the short questions go. Now, as you are looking at a short question, here is an example of one. Here is one sample. So they give me a reaction. They give me a bunch of trials here, and then they ask me some questions. These questions are meant to build on each other, and what may happen is that sometimes I need an answer here to help me answer this question. Not always. Now, of course, this is building on each other based on the test writer. That's not you. You don't think the way the test writer does. So you may be able to answer another question before the first one. And if that is the case, then you know what? Don't be afraid of answering that. The last question that they generally have here is one that asks you to think a little bit broader, a little bit more than what this question is asking. It wants you to think theoretically. It wants you to explain something, which in this case, this is a kinetics question, so that would be covered with by kinetics. So certainly, these are some of the questions that you may want to look at, especially if you're running out of time, because you may be able to answer this question even though you don't have time to do the calculations for these. Okay, so what I did here is I went ahead and I said, okay, let's, to give myself a little bit more room, I just said, okay, here's question A. Let's take a look at what's happening here. Now, what you learned in school is if you want the order of each reactant, what you want to do is if you write out the generalized rate law, you know the rate of a reaction is equal to the rate constant times the concentration of the reactants raised to their respective powers. So here I will have NH4 plus raised to some power A, and I will have NO2 minus raised to some power B. And the idea now is to find these powers first, because I can do that here. And once I find these powers, then I can use any single trial that I want to find the rate constant K. And that's going to give me the full rate equation. So taking a look at what's happening, ideally I want one of these reactants to be held constant and the other one to be changing. So here I notice that between trial 1 and 2, notice that the concentration of NO2 is held constant, while the ammonium concentration has doubled. As the ammonium concentration has doubled, the rate has doubled. So essentially, what I have is, now this is an equation you could use. You could say R1 over R2 equals concentration of Y1 over concentration of Y2, where Y1 and Y2 are reactants, to the power little y. Because these are in the same ratios, I know that for ammonia, A equals 1. Okay, so now I can rewrite my rate law as K times the concentration of ammonia to the first power. And sometimes what I will do, depending on how much time I have, I will take the time to write 1, especially if I'm rushing. Why? Because then I know I haven't forgotten it. It is actually written down and it happens to be 1. And this is the one I need to look at. Okay. Now, they were not very nice here because they did not keep the concentration of ammonia the same. Oh, but they did double this one. Okay. And they gave me a new rate. Now, what do I do here? Well, okay. What I can do is I can say rate 1 over rate 3 is equal to the same constant, concentration of ammonia in rate 1, which is 0.01 times concentration of the nitrate, 0.01 to the power B divided by K. And this is 0.015 and 0.02 to the power B. Okay, and I know rate 1 over rate 3 is 0.025 over 0.150. Now it's It's a lot easier if I had written this as rate 3 over rate 1. But as you are doing the problem, and the reason I wrote it this way is as you are doing the problem, now you know you need to flip it. So now you know to save time, next time when you do it, what you want to do is you want to write this, you want to write it as R3, rate 3 over rate 1, not this way because it saves you a step. That tiny little step that it saves you 4 times over gives you enough time to actually do another part of a problem. So if I take a look at this, what I get here is I get 0.150 over 0.025, which is equal to, now you're allowed a calculator, and I'm going to use my trusty, it's a scientific calculator, but it's not a graphing calculator. It's not as fancy as the one you would be using, but it does the job nonetheless. So this gives me 6 equals, now the k's will cancel. Okay, so 6 is equal to 0.015. Well, you know what? I can just do this, which is 0.015 divided by 0.01, and I don't even need the calculator for that. Why am I doing it? It is 1 point, come on. There we go. 1.5. Sometimes the computer needs encouragement. 0.02 over 0.01 to the power b. This means 3 is equal to 0. Well, I should just write it as 2 over 1. Yeah, not 3. What am I doing here? So that should be 4. 4 equals 2 to the power b, and now you know that b equals 2. So the rate is equal to K, concentration of ammonia to the first power, NO2 minus to the second power. Now, while we have this, I have not really answered the question. It says, what is the order with respect to each reactant? So now I'm going to say first order, with respect to ammonia, and second order with respect to NO2 minus. I know when you write the rate law, it's pretty obvious what the order of the reaction is, but you actually need to write it out like this so that it is very clear to the test writer that you know what you're talking about. And if you're wondering where these numbers came from, where first and second order came from, these are these powers right here. So we've done part A. We can move on to part B. Part B says, what is the rate constant of the reaction? Include the units. So I know the rate is equal to a constant concentration of NH4 plus concentration of NO2 minus squared. Now I can take any one of these reactions and work with it. But realize what I want to do is I actually want to take the easiest one of these to work with. Even though I have a calculator, even though my calculator can work under these, it still makes sense to take the easiest one. And if I have to take the easiest one would be trial 1, because look at all those nice numbers that I have. Okay, so here I know Okay, so the first thing, well, okay, let's put in the numbers. This is 0.025 equals k. K is the rate constant. 0.01, 0.01 squared. And what this gives me, as far as k is concerned, once again, you go to your trusty calculator. Don't try doing this in your head, especially if you have a calculator, uh, because you know it. You may actually get it wrong. So 0.025 divided by 0.01 divided by 0.01 squared equals, and now I get a k of 2.5 times 10 to the 4. Okay, so numerically, that's what I have. What are the units? The units for K, for the rate, is moles per second. Here I have moles per second. Here I have, notice that here is my rate at moles per second. This is moles per second squared. So the units for K to give me a moles per second have to be m minus 2 s minus 1. And what I'm going to tell you here is don't try and be cutesy to go ahead and flip these around. It's not worth it. Just leave it as negative. One of the things you could do is double check. Your rate is moles per second. This one here is equal to some constant k. This is moles per second. This is moles squared over second squared. So now what should this be such that all of this works out? Notice that I have 3 m's here. So I should have a m minus 2 for k. Okay. And notice that at the bottom, I have 3 s's. I have one here. So now this should be, well, hold on. Yeah, okay. So this should be an s, this should be an s minus 2 as well, okay? So that's how you would get the rate. Part C is in order to increase the initial rate of the reaction, the students suggest rerunning all these trials at 50 Celsius. Remember, these were run at 25 Celsius. Would this be effective? And justify your answer. Now, you know from the work that you have been doing is that a rate or rate of a reaction is dependent on two things. It is dependent on the temperature and it is dependent on concentration of reactants. And of course, if I can spell, right? Concentration of reactants. So what are we doing here? As we are increasing the temperature, we are doing a couple things, right? So increase the temperature. Now remember, we need to have collisions here. So if we increase the temperature, that means we have more collisions. And we also have higher energy collisions. Which means that overall, I will have more successful collisions, more product. Okay, or I should say more product, but actually a higher rate. More successful collisions, that means higher rate of reaction. Okay, so that is how the student is justified, and this is how you can justify your answer as well. Okay, pretty cool. I'm going to assume things are pretty cool. Awesome. Okay, let's take a look at this one. Now, when they give me big, long names like this that take up almost half the alphabet, I am just going to call it S acid. Sometimes they will give me some really long names here from biological molecules or what have you. Whatever they give me, S acid is good enough. They're not going to ask me how to pronounce this acid anyway, so it doesn't matter. Okay, so they tell me that it is a weak diprotic acid. Now, A says write out two acid-base dissociations that occur when H2SO3 is mixed in water. Now, notice this is not H2SO4. This is H2SO3. But we could use the same, what we've learned before. So what we've learned before and what we know about H2SO4. So the first, so what I'm going to do here is I want to actually write it down such that it's clear to the test writer. Remember, the clearer I make my work for the test writer, the more likely I am to get the points I deserve. So what I do here is I write down first dissociation. And the first dissociation is when I have H2SO3 is going to dissociate into HSO3 minus plus H plus. Okay, and the second dissociation is when I have HSO3 minus dissociating into SO3 minus 2 plus H plus. Now, if they don't ask me for the overall, then I'm just going to leave it this way. I'm not going to do anything else. If you want to be the alternate way of writing this as well, if you want, is you could write it like this as well. That would be H2SO3 plus H2O, which would give you HSO3 minus plus H3O plus the hydronium ion. Okay, and then the second dissociation would be HSO3 minus plus H2O to give you SO3 minus 2 plus H3O plus. Either way, it's correct. It works both ways. Whichever your preference is, that should work. So looking at this, notice that they gave me an easy question. Here is where they actually want me to use what I know of this question. So let's take a look at this. So they tell me a 0.5 molar solution of H2SO3 has a pH of 1.1. Determine the Ka1 for H2SO3. Okay, one of the reasons why they ask for Ka1, now we may go into a tizzy to say, hey, what about the second dissociation, right? What about that one? Well, if I have a weak acid, even if it's a diprotic acid, realize that the difference between Ka1 and Ka2 is typically 3 or more orders of magnitude, 1,000 times more or more. So the second dissociation is not going to matter. We assume, we think of it as a monoprotic acid. Okay, and that's the way we are going to work this, because the answer will be so close, it doesn't matter. So here I know Ka is going to be, well, okay, let me write out the reaction first. So the reaction is H2SO3, which is now in equilibrium with H plus HSO3 minus. Okay, so Ka is products over reactants. This is H plus. This is HSO3 minus over H2SO3. Now, if I know the pH is 1.1, that means the concentration, if pH is 1.1, that means my concentration of H plus is 10 to the negative 1.1. Okay, and I can actually go ahead and use that in my calculation if I need to. So 10 to the power 1.1 negative gives me on my calculator 0.079. Okay, 794, if you will. Well, I should be working to, yeah, okay, fair enough. 7.9 would have been good enough. So you can do that on your calculator and you should be fine. It turns out that these two concentrations are the same. So now I can write my Ka as 0.079 times 0.079 over 0.5. Why is this 0.5? Because while we may have some amount X dissociating, this amount is so small that for all practical purposes, it's still 0.5. Okay, so now if I do the numbers, 0.079 squared divided by 0.5 is going to give me 1.2. 1.25 times 10 to the minus 1, 2. Okay, cool. Pretty straightforward, hopefully. This is the more quantitative part of Gen Chem that you'll be working with as far as as far as acids and bases are concerned. They have applications in other areas as well, but really this is what a lot of this is all about. You know, with Gen Chem here, it's uh, a lot of calculations, but there are things that you can do with these calculations that actually are pretty meaningful. So for instance, what happens here? Well, if you have indigestion, the pH of your stomach and things like that are pretty valuable. So this is where they are used. They may seem like abstract calculations here, but do have real world applications. So let's take a look at a slightly different problem now, not acids and bases. If you're wondering what happened to sample question 3, that was another acids and base problem. So let's take a look at this one. It says, okay, you joined late. Now for part A, really the question was write out the two acid-base dissociations that occur when it is mixed with water. So all they are looking for is the equation. They are not looking for an explanation there. Just an equation. Okay, the chemical reaction equation. Okay, single magnesium atom will be ionized when exposed to energy with a frequency of this. Okay, and they ask what is the wavelength of light that would be required to ionize magnesium, what is the first ionization energy, um, and how would the required frequency of an ionized atom of magnesium compared to the required frequency to an ionized atom of sodium, and justify your answer in Coulombic attraction. Okay, so this is one of these things that is covered later in the course. Sometimes it is covered very quickly. So before you even want to start to tackle this question, maybe it's a good idea to make a note of the equations that you need, especially for questions like this. So I know the energy is equal to hf, where h is Planck's constant. I know the velocity of light is equal to frequency times wavelength. Okay. Uh, and these are basically the equations I want to work with here. It's okay to write them down so you have them, and these might be awesome. I love it when you see okay, I see. That's great. Now we may use these equations, we may not. It doesn't matter. One of the things it does for you, and you may say, well, I just want to write the equations that I want to use. Well, what about if I don't have to use an equation, I don't want to spend the time to write it down. Yes, well taken. But here is what happens. If you know that you have written down all the equations that you know, you've gone through a brain dump, so to speak. Um, Now, when doing the problems here, you can rest assured that you can look up here where you've written them down, and you know you will see all your equations. It actually lowers your blood pressure a little bit. It brings down the stress levels a little bit. You're not going there at the middle of question B saying, ooh, what is the question? What is the formula? I can't remember it. I've now been frozen. Um, if you don't remember a formula and you know that there is one, well, remember you can always say, well, maybe I may not need it. So let me start the question. And if I need it, it's hopefully going to come back to me. So you get your subconscious part of your brain working as well to remember an equation that you may or may not need. But certainly you are thinking in terms of the subject at hand, and that will make you sharper. Remember, on test day, it is just as important as what you know, what you have in your brain, as your state of mind. So if your state of mind is extremely calm, you will be really calm as well, or you will be calmer. You may not be calm. If you're like me, type A personality, you'll be nervous no matter what. Uh, so, writing down the equations like this may actually help you. So let's take a look at A. It says, what is the wavelength of light that would be required? Okay, so for A, what I would do is I know that C equals F lambda. This means that 3 times 10 to the 8 over the frequency, which is 1.86 times 10 to the 15 equals lambda. Okay, and now you can go ahead and run these numbers through your calculator, and when you do that, you will get actually 1.16. Yeah, can't even read my own handwriting. 1.61 times 10 to the minus 7. Okay. Now, what they do is they tell me, what is it in nanometers? Oh, well, nanometers means 10 to the minus 9. Nanometer is equal to 10 to the minus 9 meters. So this is equal to 161 nanometers. Okay, so that is part A. Part B asks, what is the ionization energy? So now I have to use this equation that I wrote down right here. Okay, so this tells me H equals H frequency. Now, if you know this as nu, that's okay. Sometimes we write frequency as nu. So when your friends ask you what's nu, you can say C over lambda. I'm kidding. It's probably not what they mean anyway, but you can do that if you like. So now let's actually put in the numbers here. Okay, this is what's nice is I can use the equation straightforward here. So Planck's constant 6.626 times 10 to the minus 34. And this is, of course, joules second times the frequency that they give me is 1.86 times 10 to the 15. And that should give you 1.23 times 10 to the minus 18 joules. Okay, now what you have to realize is that this is for one atom. What they're asking me is joules per mole. Okay, so now if it is joules per mole, what I need to do is I need to multiply it by the number of atoms in a mole, which of course is Avogadro's number. And because they want the answer in kilojoules, I have to make sure that I convert from joules to kilojoules. So I'm going to go 1.23 times 10 to the minus 18. This is joules over one atom times 6.02 times 10 to the 23 atoms over 1 mole. So notice that my atoms cancel out. Okay, and now so I have joules per atom, and now I'm going to multiply it by 1 kilojoule over 1,000 joules. And now my joules cancel out. So now what I'm going to get is, as my final answer, if you put it in your calculator, you actually get 740 kilojoules per mole. Okay, and that is your answer for part B. Pretty cool. A whole lot of plug and chug, I know, but and that's what you're going to find out in a lot of the chemistry that you do. The concepts are really simple. We get caught up in the mathematics, and sometimes that is the bigger challenge than the concepts themselves. The concepts themselves are very short. Uh, they they are virtually common sense type. You can derive them yourself. Um, it is the math where we all get caught up. So now let's take a look at part C. So for part C, basically, I know that a sodium atom is larger than magnesium atom, right? And that is due to fewer protons in sodium. Okay, so this means, and we also know that both atoms have same principal quantum number, i.e. that means their electrons are in the same, roughly the same radius, which is, or same quantum energy levels, which is the same thing. It doesn't matter which one you want, right? So as the valence electrons for sodium are further out, because it has fewer protons, okay, we know it's going to take less energy to ionize sodium. Okay, now what's the question asking? The question is it asking about energy? Because a lot of people would stop here. It is asking about the required frequency. Okay, so we've justified our answer using Coulombic attraction, right? But we haven't answered the question. We've said less energy, but we haven't answered the question as yet. So we have to say, since energy and frequency are directly proportional, okay, the frequency to ionize sodium will be lower. Okay, now I wrote this way for a very specific reason. If you look at the question again, it says compare the frequency of magnesium compared to sodium. And you can say, Dr. H, that's being picky. It's being picky here, yes, but realize in a multiple choice, they may give you the reverse. So what I need to do here is I actually need to go back and say not this, because that's not what they want. I should be saying the frequency to ionize magnesium will be higher than the frequency to ionize sodium. Okay, so while this is not a multiple choice, it's a good point for me to bring up that make sure that you actually read the question and answer the question specifically, because otherwise, yes, you have the knowledge, but you actually didn't answer the question that they were asking you to answer. Sometimes they can get picky about it. Usually it's in the multiple choice. It's usually not here in the short answers, but if you make that a good habit, you don't know what kind of college professor you will have a stickler for something like this or not, especially if you take computer programming classes. Some of those professors can be real sticklers. Okay, so let me go ahead and jump ahead to basically how do you answer the short questions, right? Approaching the short question section. So the way you do that, now this is of course assuming you have a paper test, scan the questions. What you want to do is you want to rank the questions, and the ranking is like this: easy, medium, difficult. Okay, and what you want to do is you want to start with the easy questions and work your way to the difficult ones. What you want to do is you want to complete all parts of the question before moving on. Okay, so when you're done with, let's say, question number two, well, two is going to be a long one. Let's say you're done with question number five. You're done with question number five. You're not going back to question number five. What that does is, first of all, it makes you a sharper test taker. It's a one and done for you. And if you know that, and if that is the way you practice, you will actually be a more efficient test taker. Yes, you may make some small errors, but imagine going back to correct an error to get half a point when that same time could have been spent on a question you haven't done to pick up a point or a point and a half. Okay, so that's why I say when you're done with a question, you are done because you have more points to pick up someplace else. Okay, so keep in mind that the later parts build on the earlier parts. Now, if you do not reason the question the same way as the question writer did, okay, it may not build for you, and that's okay. Uh, you know, do the parts in order, but don't be afraid to do a later part if it's easier. So the default is do the parts of a question in order, A, B, and C. But if you know the answer to C before you can answer B, go ahead and write that answer out. The last part is generally a conceptual part. And if your understanding of Gen Chem is conceptual, then do it. Most Gen Chem books that are out there like to give you a big picture of what they are talking about. And that is why these parts are typically a little bit easier. And besides, Gen Chem concepts tend to be a little bit, well, okay, so conceptual questions for the sciences tend to be a little bit easier because the concepts are supposed to reflect reality. They're not as complex as reality, and therefore they are simpler than reality. Therefore, at least I think that the conceptual parts would be straightforward. Okay, so preparing effectively for the AP chemistry. What should you what should you do? You should know the format and the instructions ahead of time. You saw me make some errors here as I was going through. Some on purpose and some because I was just nervous like you guys would be, right? Uh, well, uh, if you practice under conditions, under timed conditions, if you practice under test conditions, then you know this already. You've actually gone through your workout, so to speak, your test workout. Understand the content that will be tested and practice under test conditions. Remember, if you like watching pro sports, that great games are won not on competition day. They're actually won on the practice field. Okay, so make sure your practice field practice is there to get you the scores that you need. Yes, there will be nerves on test day and things like that. So you may not be performing at 100%, but if you've done enough practice, you will be at 80%. And besides, just like at pro sports, every time they do a practice, they review their practice. They see what they did wrong, they see what they did right, and then they try to do more right and fewer wrong. So that's where the adjust and review comes in. So go ahead and adjust and review your what you are doing so that you are good to go. Remember, one practice test does not help. You need to go through 3, 4 cycles of a practice test completely and reviewing them thoroughly before you are ready for the real test. So take the time and go through that. Don't let the actual AP be the learning curve for you. And most important, celebrate after the test. Do something that you look forward to and know what it is. Don't let it be a surprise. This way you have something to look forward to at the end of the test, after you're done with your test. No matter how you did, this will be sort of your reward for not the score that you get on your test, but for the hard work that you've put in. Because the work that you've put in is going to pay off. It may not show itself as an AP score, but it'll show itself in other areas when you go to college or something. You will be able then to excel in that class. or at least understand better and help out your fellow classmates. So how can we at Princeton Review help you? There are a couple ways that we can help you, a few ways. One is through our live streams. Now at Princeton Review, what do? Our strength is how to take the standardized test. What I wanted to do today is focus on the technique of taking a standardized test. There are many, many resources available to you to study the content. And besides, in an hour or in 3 hours, if you look at all 3 of the Gen Chem sessions we have, I can't cover all the content. What I can cover is some of the techniques that will help you. I think I hope they have an immediate impact on your performance. So if you think they do, let Shadna know. If you think they don't, let Shadna know that as well, so that we can adjust our streams, our live streams, so they are better suited for you. We have tutors and instructors ready to help you with the AP format, and the resources we have are live streams like this one. We have scheduled tutoring. We have on-demand tutoring as well. And then we have our AP cram courses. The AP cram courses are designed to actually give you the content that you need. So as you get the content, now at least you know where to study, where your gaps are, where your strengths are. And typically with these courses, they try to give you an idea of the level of depth of content you need for the various AP courses. How else can we help? Okay, we have our AP books out there. These books do contain full-length tests, typically 3. The AP Chemistry Premium has 5. The AP Chemistry Prep has 3. And then there are some online tests. I think the AP Premium gives you 2 online tests as well. So they are resources out there. And even if you don't use a Princeton Review resource, use some resource. At least try and make sure that you are taking a few, 2 or 3 at a minimum, full-length tests or simulated full-length tests before the actual test. It is amazing how much these will actually reveal to you where you need to work and where the areas that you need to strengthen and the areas where you're okay at. I've had people tell me, hey, Dr. H, I need to work on this particular area, kinetics, for instance. And then when I talk to the student, it's like, enough about kinetics. It's like one concept or 2 concepts. You know those concepts. So just because you didn't spend a whole lot of time doesn't mean you don't know it. So at this point, I will take any questions, comments, or feedback that you may have. And if you don't, I will see you tomorrow. And just before you go, I want to let you know that tomorrow I want to spend a couple of slides talking about specifically techniques for the digital version. We've spent quite a bit of time talking about techniques for the paper and pencil test, but I do want to actually touch upon the digital version and what you can do. Now, granted, they've limited you so much that you may not have a lot of room to maneuver, but there are some things that you can do as well, and that's what I want to discuss tomorrow. So I will, if there are no questions, there are no comments, I will see you tomorrow, hopefully.